Okay, so this is action code E, which is about reacting masses, and I'm going to show you the method that I showed you in lesson. I'm going to use the method that I showed you in lesson, okay? And this comes from the higher section of your syllabus, and it's possibly one of the more difficult aspects of the syllabus, okay? So it's statement Q, okay? So the first question says, copper is an important metal in everyday life. It can be produced from its oxide by heating with carbon. The equation for the reaction is shown below. So you take 2 moles of copper oxide, react them with 1 mole of copper, which makes 2 moles of copper oxide and 1 mole of carbon dioxide. So we'll just put in the invisible numbers just so that we're clear where we're up to. The question says, use the equation to calculate the maximum mass of copper. One thing we're interested in, so that's the copper, that would be produced when using 1.5 tons of carbon. So the other thing we're interested in is the carbon. So as far as this question is concerned, we don't need to worry about the copper oxide or the carbon dioxide. From the equation, we can see that 1 mole of carbon produces 2 moles of copper, and that's some important information that we'll need. Okay, so if we draw our formula triangle, on this side we'll do this one for carbon, and we know from the equation that 1 mole of carbon is involved in this equation, and on the other side we'll put our copper triangle. We know from the equation that there's 2 moles copper. So if we fill these triangles in with the information we're given in the question, we know that in the question there's 1.5 tons of carbon, so we can put that there, 1.5 tons, and we want to know what mass of copper that can make. So in order to know that, we need to know how many moles carbon are actually in 1.5 tons. Okay, so to find that out, we need to know the MR of carbon, which is 12. And if we do the calculations suggested by the triangle, 1.5 divided by 12 gives us 0.125 moles. Okay, now at this point we need to remember that that's equivalent to 1 mole of carbon, but for every 1 mole of carbon we produce 2 moles of copper. So the number of moles of copper produced, so taking this value and placing it into this part of the triangle here, we need to remember we go from 1 mole to 2 moles, so that gives us 0.25. Remember, we want to know this value here, so to calculate that we'll need to know the MR or the AR in this particular instance of copper, which is given to us in the question as 64. And when you have two numbers side by side in a triangle, it means multiply them together. So 64 times 0.25 is 16. So that tells us that we've got 16 tons of copper. Okay, so for every 1.5 tons of carbon, we make 16 tons of copper. The next question, so 2 stages to it. Similar story. So the overall reaction taking place is shown in the equation below. So we've got 2 moles of sodium chloride makes 2 moles of sodium and 1 mole of chlorine. When carrying out the reaction, 120 grams of sodium chloride, so it would assume that sodium chloride is a chemical of note, was found to produce 38.05 kilograms of sodium. Okay, so we're interested in those two, so we don't need to worry ourselves about the chlorine. Okay, from this equation we can see that 2 moles of sodium chloride make 2 moles of sodium, okay, which as far as we're concerned is a 1-to-1 ratio, okay, for this particular question, because we're not worried about the chlorine. So if we set up our triangles, this one is going to be for sodium chloride, okay, so this is NaCl, and in this case we're going to treat it as if there is 1 mole that's going to react and produce 1 mole of the other chemical of note, which is sodium. Okay, now we know it's 2 to 2, but this is a ratio thing, so we can treat that as a 1-to-1. So if we fill the triangles in with the information that we've got, we're told in the question that there's 120 kilograms of sodium chloride. We want to know how many moles of sodium chloride that is equivalent to. So we need to know the MR of sodium chloride. So if we add 23 and 35.5, which would give us the MR of sodium chloride, that gives us 58.5. And in order to calculate this missing value, we take 120 and divide it by 58. That's what the triangle is telling us. And if we do that, we get 2.05. Okay, that's done that on a calculator previously. So at this point, we can now transfer information from this side over to this side. So we know it's a 1-to-1 ratio, so we don't really need to write it, but we'll put the 1 in there, and that comes up there. So that means that we're going to be making 2.05 moles of sodium. In order to work out the mass of sodium produced, we need to know the AR or the MR. It's AR in this case because it's an element rather than a compound. So that's 23. And two numbers sat adjacent to each other in a triangle means multiply them together to get the missing one. So if you do 23 times 2.05, you get 47.15, which we can convert to 47.2 kilograms. Okay, so that's the theoretical yield. That's how much we should get, but industrial processes are always a bit wasteful and dirty and things get lost. So in actual fact, in this particular instance, they only made 38.05 grams of sodium. Okay, so in order to work out the yield, we take what was actually made, 38.05, divide that by 47.2, times by 100, and that gives us a yield of 81%. Okay.